Hi, hello. So these are the questions I'm going to cover in this lecture. The chapter is production and costs. So let's start with the very first question, that explain the concept of a production function. What is a production function? See, the production function of any firm is a technical relationship between inputs used and the output produced by that firm. Now, for various quantities of input which are being used, it gives the maximum quantity of output that can be produced. So it's a kind of technical relationship between input and output, and the purpose or the aim is maximum quantity of output that can be produced. Now it is also defined as for the particular given technology, a particular production function is used. So it is the technological knowledge that determines the maximum levels of output which will be produced using different combination of inputs. If the technology improves, the maximum levels of output obtainable for different input combination increases. We then have a new production function. Like I told earlier, that depends upon the technological state of the entire process. Now, the inputs that a firm uses in this production process are called factors of production. So mainly we are very well known with or acquainted with three factors of production: labor, capital, and entrepreneur. Now there is an example that we can consider here. If, for example, if we consider a firm that produces output using only two factors of production, that is labor and capital. Here our production function tells us the maximum quantity of output which is being represented as small q that can be produced by using different combination of these two factors of input, factors of production, labor and capital. Mathematically, this can be written as Q, which is the output, is equals to F. F shows here the function, and within bracket L is the labor and K is the capital. So here this Q depends upon labor and capital, or we can say L and K. Moving to the next question, what is the total product of an input? So here we'll take an example. Let us consider a situation where if we vary a single input, keeping all the other inputs constant, then in that case, for different level of that particular input which is variable, we get different levels of output. This relationship between the variable input and output, when all the other inputs are being kept constant, is referred to as total product of that input which is variable. So this is the total product of an input. Remember here, all the other factors of production are being constant, only keeping one input variable. So in that case, the relationship between total outcome or the total product and that variable input will be the total product of that input. Again, we'll take an example here to understand it in a better manner. This table 3.1 here, which shows the production function. For example, suppose if the factor of production capital is fixed at 4 unit. You see this column here. So suppose if it is fixed at 4 unit. Now if we look at the column where capital takes the value 4, as we move down along the column, we get the output values for different values of labor, which is given here. So in this column you can see the capital is being kept constant at 4 units, and with the labor is variable, and capital is constant. So here is, this is the total product of labor schedule when capital is being kept constant at 4. And this is also sometimes called as total return to or total physical product of the variable input. You see this column. Moving ahead. Now moving to the next concept. What is the average product of an input? So average product is nothing else but the output per unit of variable input. Okay, and the mathematical formula here, AP is the average product, is the TPL. For example, we are talking about the average product of labor. L is labor here. So APL would be equal to total product of L upon L here. L means unit of labors. So it is the ratio between the two. Total product of labor whole upon units of labor being used. Similarly for K also. K is capital. Now if you see again taking table 3.2 here, the last column shows here the average product of labor, or we can say the average product of an input. See here, it is being calculated. It gives the numerical example of average product of labor when the capital is fixed at 4. So for production function described in table 3.1 that we already considered earlier, values in this column are obtained by dividing TP, that is column second here, divided by column first, which is L. So when we divide second column by first column, we get the average product of labor, which is the fourth column. So it is 10 by 1 is 10, 24 by 2 is 12, and further on. So this is how we get the average product. Now what is marginal product of an input? Excuse me. Marginal product of an input is defined as the change in output. Remember here, read each word very carefully. Change in output per unit of change in the input when all other inputs are held constant. So here again we are considering a particular input when all other inputs are being held constant. Then in that case, what will be the change in total output as a result of change in that particular input, which is kept variable, keeping all other inputs or factors of production constant. So when capital is held constant, for example, again here we are keeping capital constant, the marginal product of labor will be calculated like this. This delta TPL upon delta L. Delta here represent the change of the variable. So here if you see in this table 3.2, it gives you the numerical example of marginal product of labor when the capital is fixed at 4 unit. So for the production function, production function described in table 3.1, the values in this column, here you can see third column shows the marginal product of labor. So this value, a value in the column are obtained by dividing change in TP by change in L. For example, when L changes from 1 unit to 2 unit, the total product changes from 10 unit to 24 units. So now here what is the change in total product? It is 24 minus 10, which is 14. And what is the change in labor? It is 2 minus 1, which is 1. So marginal product would be 14 upon 1, which is equal to 14. That you can see here. And similarly, all other values will be coming here or will be calculated. So this is what is the marginal product of an input. Now let us explain the concepts of short run and the long run. So we'll consider the short run first. In the short run, at least one of the factors among the labor or capital can be varied, and therefore it cannot be varied. I mean one factor has to be kept constant or fixed. Among the factors of production, one factor of production has to be kept constant or fixed. So in order to vary the output level, the firm can vary only the other factors. The factor that remain fixed is called the fixed factor, whereas the other factor which the firm can vary is called the variable factor. For example, we are taking this table of production function here again. We'll refer to this. Suppose in this short run, that example where we took the value of capital fixed at 4 units, it was an example of short run only because here capital was fixed whereas labor was variable. So here the corresponding column shows the different level of output that the firm may produce using different quantities of labor. Since the capital is kept constant, by changing the unit of labor, we got the different quantities of different level of output. So this period where one factor has to be kept fixed, this period or this time is known as short run, whereas in the long run all factors of production can be varied. So a firm, in order to produce different level of outputs in the long run, may vary both the inputs. Like in long run, both labor and capital can vary. So there is no fixed factor. And for any particular production process, long run generally refers to a longer time period than the short run. For different production processes, the long run period may be different. It is not advisable to define short run and long run in terms of, say, days, month or year. We define a period as long run or short run simply by looking at whether all the inputs can be varied or not. Okay, so this is what is the difference between short run and long run. Now another very important concept, which is the law of diminishing marginal product. So here we are taking this table where there are 4 columns. First is labor, which is being kept variable, then its total product, its marginal product and average product. Now if we plot the data of this table here on the graph paper to understand what diminishing marginal product is or what the law talks about, we have placed labor on the x-axis and output on the y-axis, and we get the curves shown in the diagram below. So let us see first of all what happens to the total product or TP. You can see that it's moving upwards. But what is the pattern? So we can see that TP or total product increases as labor increases. So as we increase the input labor here, total product also increases. But the rate at which increases, it's not constant. For example, an increase in labor from 1 to 2 unit, it increases the total product by 10 units. Okay, from 10 to 20. But further, an increase of labor from 2 to 3 units, it increases the total product by 12 units. So it shows an increasing rate. Now the rate at which TP increases or total product increases, as explained here, is shown by the marginal product or MP curve. You can see that MP curve is rising here up to 3 units of labor. It's rising, it's still rising up to 3 units of labor. And then it starts falling. Then it begins to fall, and this tendency of first increasing and then falling is known as the law of variable proportions or law of diminishing marginal product. You can see that marginal productivity of labor is increasing here till 3 units of labor when the capital is being kept constant, but after 3 units it starts diminishing. It is increasing but with a decreasing rate. So this is the diminishing marginal product or the law of diminishing marginal product. Now what is law of variable proportions? So this law says that the marginal product of a factor input initially rises with its employment level, but after reaching a certain level of employment it starts falling. As we hold one factor fixed and keep increasing the other factor, the factor proportion changes. And initially, as we increase the amount of the variable input, the factor proportions becomes more and more suitable for the production and marginal product increases. But after a certain level of employment, the production process becomes too crowded with that variable input. So then what happens? The the input or the efficiency reduces and the contribution or the marginal product start reducing. If you see here, this in this table, you see till 3 units, the marginal productivity is increasing from 10 to 14 to 16, and then further it start falling. So it shows that, for example, if we take a farmer who has 4 hectares of land, for example, and can capital is being kept at 4 unit, as we remember. So now he can choose how much labor he want to use. First he used only one worker, so he has too much land for the worker. There was too much land for the worker to cultivate alone. But as he increases the number of workers, the amount of labor per unit of land increases, and each worker adds proportionally more and more of the total output. So marginal product increases in this particular phase. But when the 4th worker was hired, the land began to get overcrowded, and each worker now has insufficient land to work efficiently. So here the output added by each additional worker is now proportionally less. So here then in this situation the marginal product begins to fall. So that is why this phenomenon is known as law of variable proportion, when all the other factors are being kept constant and we are keep on increasing the same factor, one particular factor. So after a period of time, then the productivity starts diminishing. This phenomenon can be easily seen in the agricultural area, where the phenomenon is also known as disguised unemployment, where more than required number of people are being hired and their contribution is comparatively or proportionally less. Moving to the another very important aspect, what does a production functions, when does a production function satisfy constant return to scale, increasing return to scale, and decreasing return to scale? So let us assume a situation. We already studied what a law of variable proportion is. So the law of variable proportion arises when factor proportion changes, as long as one factor is held constant and other is increased. But imagine a situation where both the factors can change, which can definitely happen in long run. So in one special case in the long run there occurs when both factors are increased by the same proportion, or factors are scaled up. Now when the proportional increase in all input result in an increase in output also and in the same proportion, then the production function is said to display the constant return to scale, or CRS. That you have increased both the factors of production, the output has also increased, and the output has increased in the same proportion. This situation is the constant return to scale. Now the second situation is when a proportional increase in all input result in an increase in input by a larger proportion. In that situation, the production function is said to display increasing return to scale. Inputs have increased, and what is happening? The output has also increased, and even in the larger proportion it has increased. So this situation is the increasing return to scale. Now let us consider a production function where Q is the output F is the function, x1 and x2 are the factors of production, where the firm produces q amount of output using x1 amount of factor 1 and x2 amount of factor 2. There are two factors of production. Now suppose the firm decide to increase the employment level of both the factors. Okay, where factors t, where t is greater than 1 times. Mathematically we can say that production function exhibit constant return to scale if f tx1 comma tx2 is equal to t times f x1 comma x2. That is, the output has increased in the same proportion to that of the increase in the inputs. That is, the new output level will be f, t will get inside and get multiplied with the two units of factors of production, two different units, x1 and x2. So it becomes tx1 comma tx2, which is exactly t times the previous output level. And what was the previous output level? It was f comma under bracket x1 comma x2. So this shows the constant return to scale. Now for increasing return to scale, what will happen? This ftx will be this new function or the new output will be greater than the earlier output, which has been shown here mathematically as function of tx1 comma tx2, which is the new output, is more than, proportionally higher than what was the initial production function. Whereas in decreasing return to scale, what happens? It is less than, the new output will be lesser than the initial production function. So decreasing return to scale holds when a proportional increase in all the inputs results in an increase in output, but by a smaller proportion. For example, suppose in a production function all inputs get doubled. Now as a result, if input gets doubled, the production function exhibit CRS, that is constant return to scale. If output is less than doubled, then DRS holds. Like we have doubled the inputs, but the output is not being increased in the same proportion. In fact, it has increased, but in the proportionally lesser amount or units. So it's lesser than the doubled value, then decreasing return to scale will hold. But if it is more than doubled, then IRS or increasing return to scale will hold. So this is how it goes, all the concepts goes. Now as you already know, I talk about this portal of mine where you can join my live classes. Both the UG and PG students can join here. They can have their demo sessions here, free demo sessions here. They can have their PDF notes there. So get registered and keep studying. I wish you good luck. Thank you so much.